Let's find vector components. We've discussed adding two vectors to produce a resultant vector. Now, is it possible to reverse the process? Can we decompose a given vector into the sum of two vector components? The ability to do this is necessary for many applications in physics and engineering. For example, finding a force required to keep the cart from rolling down the ramp. In other words, how much force do you have to push behind to keep it from rolling? We'll work this problem later. Let's look at the definition of vector components. Let u and v be non-zero vectors such that u is w1 plus w2, where w1 and w2 are orthogonal and w1 is parallel to or a scalar multiple of v as shown in the diagrams at the right. The vectors w1, w2 are the vector components of u. The vector w1 is the projection of u onto v, and it is denoted by w1 equals the projection of u onto v, and we see how vector w2 comes into this. The next question is, how do you find the projection? So we have a formula here for the projection of u onto v. U onto v. The dot product of u and v divided by the magnitude of v squared times the vector v. Let's look at an example. We want to find the projection of u equal to 4, 4 onto v equal to 3 minus 6. So we have the projection of u there, we have the vector u, we have the vector v there, and so notice how I extended v so that I could do a projection. Notice the projection is perpendicular. So w1, which is what we're looking for, is the product of those two dot products times the vector 3 minus 6. So we have 12 minus 24 over 9 plus 36 times the vector 3 minus 6. And so when we do the arithmetic, that is minus 4/5, 8/5, and that is the projection of u onto v. W2 then is 4, 4 minus 4/5, 8/5, which when we do the subtraction is 24/5 and 12/5. So W1 and W2 are orthogonal, which is what we wanted them to be. Here's the projection, and we have orthogonal since the dot product is 0. Now here's our little red cart. A 200-pound cart is on a ramp inclined at 30 degrees. What force is required to keep the cart from rolling down the ramp? All right, the force is vertical and downward. So force equals 200 times the cosine of 270i plus the sine of 270j. So the force is equal to minus 200 in the j direction. So V equals the cosine of 30i plus the sine of 30 in the j direction, which equals the vector square root of 3 over 2, 1/2. Now, we need the projection of F onto U, all right? And so from the formula in the previous video, we have the product of those, or excuse me, the quotient of those two dot products times our 32i, and if you notice there I'm kind of overlapping, which is terrible, but I think you can read it. Right? Remember, the force is minus 200 times j, so that would be minus 100 pounds, because minus 200 times 1/2 is minus 100. Right now, let's push a desk across the floor. A constant force of 90 pounds exerted at an angle of 25 degrees with the horizontal is required to slide a desk across the floor. Determine the work done in sliding the desk 15 feet. All right, work is equal to, and we have this formula from physics, work equals the magnitude of the projection of F with respect to PQ times the magnitude of PQ. All right, so we have 50 pounds, which is the force, so the cosine of 25 times 50 times 15 gives us 679.7 foot-pounds, which is the force required to push that desk.